Hello everyone, I'm here to give you a simple example of the LeetCode problem. The smallest subtree with all the deepest node. And here in LeetCode, we already have a solution. The second approach, which uses recursion, right? To be precise, it uses DFS call. So what I will do is to give you a simple example and to explain this solution, right? So let's begin. Suppose we have an input tree like this, and we want to get the smallest subtree with all the deepest nodes. From this tree, we can see that the deepest nodes are 7 and 4, right? The depths of them are 1, 2, 3, all three, right? And 7 and 4 have the same depths, and they are all the deepest nodes, so we should return this tree, right? So the result should be 2, 7, 4, right? And now let's begin our process to get the result, right? And we use DFS call, right? So firstly, we add here, and then we should call the DFS method on the left node, right? So we are here right now, and then we call the left tree again, and we are at here, right? And then we call the DFS again, and the left tree, we call the left tree, and as it is now, right? So we return now to the upper layer, and then we go back to here to call the red tree, right? And it is now, so we return 0 here. So here we go back to here, and we do the check thing, right? We check the left result and the right result as the distance are equal. So we return this node, and our distance should be added to 1, right? So we return 6, 1 to this layer, right? And we go back to here, right? And the left subtree, return 6, 1. 6 is this node, and 1 is the distance from 6 to 5, the node 5, right? And then as we're in this layer, and we have already called this traverse the left subtree, and the next thing is to traverse the right subtree, right? So we go down here, and then we firstly explore the left subtree, right? So we go down here, and then at 7 and the node 7, we traverse the left subtree and the right subtree, and they all return now 0, right? So we go back here, we do the check thing, as the left subtree and right subtree returns the same distance. So we return this node 7, and our distance should be added to 1, right? So we return the result 7, 1 to the upper layer, to this node 2, right? So for node 2, we have already explored the left subtree, and then we explore the right subtree, right? So we are here again, we explore the next subtrees, and they are all now, so we return 0 here, and we do the check, we return for 1 here, right? So currently we are at node 2, and we have already explored left subtree and right subtree and get the results, right? So we do the check, as left subtree's distance is equal to right subtree's distance, so we should return this node, and our distance should be added to 2, right? So we return 2, 2 to here, and at this layer we have already traversed or explored the left subtree and right subtree, and the return results are here. We do the check thing as for the right subtree, the distance is bigger than the left subtree, so we return this node, and the distance should be added to 3, right? We should add 1 on this distance, right? So we return 2, 2 here. So basically this is the idea of the LeetCode solution. And as for this node, we have already traversed the left subtree, right? And the return result is 2, 2, and the next thing is to traverse the right subtree. I will not talk about this in detail because it is same as traversing the left subtree. So basically, we go down here, and explore the 2 null subtrees, and we return here, and we do the check and return here, and then we explore the right subtrees, right? And we go down here, and we return, then we do the check, and we return here. So basically, the final result should be the node 2, right? And we just need to return this tree, and as and node 2 is the final result tree's root, right? So that's all. Thank you.